Mr. Abbott here, and it's time for another boring diagram explanation. This one is number 30. Definitely, this is topic 7, which is weather. And when you look at these models, the earth science phenomena that they're showing is lake effect snow. So let's start working on this. So, as we said, this is topic 7. And this is giving you information about lake effect snow. Now, the best place to start with this is the Earth Science reference tables on page 2, which is the landscape map. Okay. So, when you look at New York State, you'll see on this map, which is page 3 actually, you've got two Great Lakes. You've got Lake Ontario and you have Lake Erie. Now, New York happens to be on the eastern side of both of those Great Lakes. And when you look at these Great Lakes sort of have their long direction, their long axis is running from west to east. So when we go to this map, which even shows you a broader area, okay, you've got Lake Ontario, okay, Lake Erie. Both of the lakes are running east to west, and in our area, our air masses tend to move from west to east. So before air masses reach New York State, frequently, if they move across the Great Lakes, they're able to pick up more moisture if the lakes are not frozen. Now, right next to the Great Lakes, there's a landscape region which is called the Erie, Ontario lowlands. As you can see from the map, that's a plain. That means it's flat, low-lying, low elevation. But right at the end of both of our Great Lakes, there's a plain followed by a plateau. With Lake Ontario, you have the Tug Hill Plateau, but at the end of Lake Erie, you've got the plain followed by the Allegheny Plateau. So this sets up a perfect mechanism for creating lake effect snowstorms. And upstate New York frequently gets hammered by lake effect snows. Last year in Buffalo, they had 7 feet of snow in one 24-hour time period. And there were cars and buses stranded on the New York State Thruway for, over a day because the snow was so heavy. So let's go back to our models and take a look at this mechanism. Okay, this illustration shows cold air moving across Lake Ontario with arrows moving upward. Usually what we're going to get is cold, dry air or continental polar air masses moving across the Great Lakes. Okay, the arrows moving upwards are showing you evaporation. So you get evaporation is going to add water vapor to those dry air masses. And since they're dry, that really allows the evaporation to occur fairly rapidly. The air moves west to east across the Great Lakes. And since Lake Erie and Lake Ontario run that same direction, there's several hundred miles where those air masses are picking up moisture. Now, when it hits New York State, New York is downwind of the Great Lakes. So in New York State, if you get any lifting of the air, rising air expands and cools. So we get the air is forced up a plateau. When the air gets forced up the plateau, we've talked about RAC before, rising air expands and cools. That leads to cloud formation and then snow. So you can get very localized, rapid snowstorms, okay, because of this lake effect. Now, along Lake Ontario, some locations that get a lot of snow are places like Syracuse, New York. Okay, Syracuse, New York sits right by the Tug Hill Plateau, and the Tug Hill really forces the air upwards. The rising air expands and cools, and Syracuse gets 300 inches of snow a year. Other places like Oswego, New York, and Watertown, New York are also going to get lake effect snows that are associated with Lake Ontario. Now, the second model that came from a different regions essentially even gives you more characteristics. You've got warm lake water. Okay, usually the water is going to cool down slower because water has a high specific heat. So it takes longer for the Great Lakes to cool down than the surrounding land masses. Okay, because the lake water is warmer, you're able to pick up excess moisture as the cold air flows west to east across the Great Lakes. Now, they did not label it, but you can see that this flat, low-lying area, this would be the Erie, Ontario lowlands. Adjacent to it here, once again, this would be the Tug Hill Plateau. Now, we also get lake effect snows if we're dealing with Lake Erie. So if we consider Lake Erie, okay, Lake Erie is essentially what gives Buffalo, New York, incredibly high snowfall totals. If you go to Buffalo State, they have tunnels between the buildings, so if it snows, it doesn't matter, you can still get to your classes. But if we're looking at Lake Erie, okay, here's Lake Erie. Okay, you've got the Erie, Ontario lowlands, but then right next to it, you have the Allegheny Plateau. So with Lake Erie, Buffalo, you'd get Lake Erie, then the air is forced up the Appalachian Plateau. Okay, that's why areas around Buffalo get really hammered by lake effect. Okay, now one thing that will happen is if the lake freezes, which will happen some really cold winters, the lake effect stops. Okay, you've got to have warmer water and unfrozen water. Okay, if we just looked at this model, and you can imagine ice forming over here, once this completely ices over, that means that the evaporation is going to stop and you're not going to get as much snow. So if this is ice covered, okay, maybe late January into February, the Great Lakes completely freeze over, that's essentially going to cut off or shut down your lake effect snow. Now, you should see that this is similar to the orographic effect, and it's sort of like on the windward side, you're going to get rising air, but now you're going to get snow on the plateau because the air gets forced to rise. I hope that gives you an idea of these models and how they're explaining the phenomena of lake effect snow. Take care.